Hey, this is Josh from Zerto. Welcome to this video on installing Zerto Virtual Replication in both a VMware vSphere and a Microsoft Hyper-V environment. For step 1, we're going to install our Zerto Virtual Managers. You need one for each vCenter or system center that you're linking Zerto to, and you're going to need a standalone VM with 2 vCPUs, 4 GB of RAM, 100 GB of disk, and a static IP address in which to install the Zerto Virtual Manager software. I've already downloaded the documentation, all the installation files, and we'll start by installing Zerto into my production VMware environment, and Zerto supports both a Windows and Linux vCenter server. We'll kick off with the VMware installer that you can see here. There are 2 different installation methods for the Zerto Virtual Manager, Express and Custom. The main difference between the two is that Custom allows you to specify a dedicated SQL database, which we recommend for any environment with more than a couple hundred virtual machines to protect. First, we specify the vCenter server hostname or IP address, and then a dedicated service account, which requires full vSphere admin permissions. We then have to set a text label for the Zerto interface on where this site is and what it should be called. And now the installer is going to check, first of all, that it can ping and communicate with the vCenter server, and then second of all, that the credentials we specified allow us to successfully authenticate, and this is exactly the same as loading the vSphere web client. We have the warning on the plugin because I've installed Zerto in this environment previously. While that's progressing, we can now start the installation of Zerto in my Hyper-V environment. Here I have a Hyper-V host, 2012R2, registered and being managed by SCVMM 2012R2, SCVMM 2012R2, which is the minimum requirement for installing Zerto in a Hyper-V environment. I have another Zerto manager with the Hyper-V installer ready to go. If we load this up, we'll do the exact same installation using the Express installation method, and except this time we're going to specify all the information for my Hyper-V environment instead. So we need the IP or hostname of my SCVMM server, the domain on which it's joined, a domain administrator account, and again a site name. It's now going to perform the exact same authentication checks. The check is now passed, so let's kick off the installation in the Hyper-V environment. We can now go back to my production Zerto manager and we can see that the installation is completed, which is then going to allow us to load up the Zerto interface, which will be on HTTPS port 9669. So let's close down the installer, open up a new tab in the web browser. Using the custom installation method, we can set our own security certificate here. We should log in with our vSphere admin credentials. Apply our trial license key. And then we can go to the Sites tab and pair this Zerto manager to every site that we want to replicate to. If you only have one vCenter, don't worry, you don't need to add a second site because by default you can enable replication within the same vCenter server to test out Zerto between the same host, couple of hosts, different data stores on the same host, or even different clusters. So we're going to specify my second vCenter server, which I already deployed Zerto onto, and I'm also going to specify my Hyper-V site. We've now successfully paired to both my target sites, and we've finished step 1, ready to move on to step 2, which is deploying the virtual replication appliances. The next step is to deploy virtual replication appliances onto each hypervisor host that we're going to be replicating from and to. This is easily done from the Zerto Virtual Manager interface by clicking on the Setup tab. You can see a list of all of the hypervisor hosts registered to the vCenter or System Center. Click on the first host and then click New VRA. First, you can specify whether to use root credentials or not to connect to the host, which is needed for any host prior to version 6. To demonstrate that, I'll just enter the root password here. If you're running vSphere 6 onwards, you don't need to enter that root password. Then we set a data store in which to store the appliance OS files. This needs around 12 gig of space, can be a local or a shared data store. Then we specify a port group for the replication traffic, which we recommended be a dedicated port group if you're protecting more than 30 plus VMs. Then you specify the RAM for the appliance. 1 to 4 gig of RAM for this appliance is enough for 95% of environments. If you've got an extremely high I/O write rate, then you can bump this all the way up to 16 gigabytes if required. The VRA group should be created if you're protecting and replicating between multiple data centers in the same vCenter. If you're just going between vCenters or system centers, you don't need VRA groups. Then we need the IP information. This can be DHCP, and we recommend a reserved IP, or you can just set a static IP as you see here. We click install, and with no maintenance mode, no downtime, Zerto is going to automatically deploy the VRA to the host, create all the HA and DRS rules to tie that appliance to the host, because you need one on each host in the clusters that you're replicating from and to. So as you vMotion VM, Zerto can carry on replicating and protecting. At this point, I can start deploying my next appliance in the cluster. I can also automate this entire process end-to-end using the REST API if I don't want to use the interface at all. And it's the exact same process for deploying a replication appliance in a Hyper-V environment too, except I don't need to specify any root credentials. It's just using all the credentials that I use for the System Center service account when deploying the Zerto Manager. Once you've deployed all the VRAs, you might want to control how much bandwidth Zerto is going to use. So that's done from site settings, performance and throttling. And here you can set a site-wide limit, and you can also configure it on a time-based throttle. Once you've deployed all these appliances, then the next step is configuring and protecting the virtual machines, done by creating virtual protection groups, or you might want to install Zerto as a cloud appliance and replicate to AWS or Azure. To enable Zerto to replicate into Microsoft Azure or AWS, you're going to need to deploy a Zerto cloud appliance, which is a Zerto virtual manager and a virtual replication appliance, all in one, running in a Windows VM or instance in the public cloud. For Azure, you're going to need a standard DS3 v2 VM, which you can deploy from the marketplace. And for AWS, you're going to need an M4 extra large EC2 instance. You need to have built-in networking between your environments. So from your on-premise ZVM VRAs, you need to have at least a VPN connection up into the network that the ZCA is deployed and attached to in Azure or AWS. You then need to download the ZCA installation files to the VM ready to install. And first, we're going to start by showing you the installation of Azure. Again, you can do an Express installation or custom. And for this demo, we're just going to stick to Express and not use our own certificate. And the simple thing it's going to ask for here is to authenticate against the Azure account on which you're going to deploy this Zerto cloud appliance to. So I'll just put in my information here. You have to make sure that this VM has internet access so that you can successfully authenticate against your account. This is now successfully authenticated, so we can select the subscription that I want to use when creating the VMs in a recovery scenario, the default directory, and then the region, which is automatically detected because whichever region I deploy the Zerto cloud appliance into is where I'm going to replicate to. One thing you need to make sure is that your account that you just specified here is configured as a subscription owner, which is not the default behavior, so you need to go in and edit that. We click Next. It's asking for the IP address, which is going to allow us to communicate to our on-premise ZVM and VRAs, and then a site name. I've actually cheated in my environment here where I'm doing a reverse VPN because this is from my home lab. I actually have a softie for VPN connecting my Azure and AWS ZCAs back to my on-premise environment, but typically in an enterprise you would have a VPN connecting your on-premise into your public cloud. Click Next, Next. It's now going to validate out and we'll click Run. While waiting for that, we can kick off the exact same installation process in my AWS environment. So I go over to my EC2 instance. Here you can see I've got the ZCA installer for AWS. And slightly different here, rather than authenticating with an online account, it's going to ask for our access key ID and secret access key, which you need to generate from your IAM settings. Keep these secure. Next. It will validate out that we can successfully authenticate. All of the replica data in AWS is stored in S3, and it will automatically create an S3 bucket for the replica data. In Azure, it's just stored as blob storage in a storage account. We can now proceed with the installation. And when this is finished, we can come back and now we can check on the progress of my installation in Azure. We can see this is now done, and if I open up the Zerto interface, I can apply my trial license key. See now, I apply the license. And this Zerto manager is now ready for me to pair to my on-premise VMware or Hyper-V site to enable replication into the cloud, which I do from clicking pair here, and then I put in my on-premise Zerto manager IP address. You can do this from either site to one-time operation. That's now paired, and we can repeat the exact same process in AWS. So now we can see that from my on-premise VMware environment, it is now paired to Azure, AWS, Hyper-V, vSphere, which is now going to allow me to create replication protection groups from one environment to multiple different versions of hypervisors, clouds, all from the same interface. A couple of quick tips for recovery scenarios is there are default quotas and limits within Azure and AWS that you're going to want to remove or change before you start recovering any VMs at scale. So in Azure, you need to create a help desk ticket and increase the number of cores available in the region that you've selected. The default is 10. You're going to want to increase that to the total number of cores that you're going to be recovering in the VMs. And then for AWS, you're going to want to change two main settings. The instance limit, so that's a maximum of 20 by default. If you're going to recover 50 VMs, it needs to be 50. And you also want to ask for the EC2 import instance volume limit to be changed to the total number of volumes that you're going to be recovering. The default is 5, which means it will only concurrently process 5 imports of volume simultaneously, which many people are going to want to increase. Once you've done this, the next step is creating the protection groups. The next step is to configure which virtual machines we want to replicate and protect. And this is done using the concept of virtual protection groups, which are created from the source Zerto virtual manager that you want to replicate the VMs from. We simply click Actions, Create Virtual Protection Group. Let's give it a name. And to start with, I'm going to try creating a local replication of a file server VM. We select a priority, which is a built-in cause of the replication traffic. It's local, so I'm quite happy to put that high. I can then search for the VM, and this is just a list of all the VMs in the source vCenter or system center. It doesn't matter which host, which data store, which cluster, it's just the VMs available to replicate and protect. You can place multiple VMs in a consistency grouping to ensure that they're all replicated and recovered together to a consistent point in time, as well as the ability to define boot ordering to make sure, for example, database VMs come online first. Then we select where do we want to replicate these VMs to. So every single Zerto manager or Zerto cloud appliance that I have paired to this Zerto manager is now available as a replication target. And it doesn't matter which hypervisor, which version, which storage, or which cloud. This is where you see the benefits of Zerto being completely agnostic to the underlying technology. So I can replicate this VM locally to recover directly to production, to Azure, AWS, cross-hypervisor from vSphere to Hyper-V, or between different vSphere versions or the same vSphere version. Really, really simple, extremely flexible and powerful. For this first demo though, let's do a local replica. And this is a production VM in my production cluster. I'm going to replicate to my second cluster in DC1. So this could maybe be a dev test cluster. And I could select the whole cluster, or I could pin it to individual hosts within that cluster. I then see a list of all of the data stores available to that host. And then I can start to configure the SLAs around the journal retention and the replication RPO alerts. So journal history is a minimum of 1 hour, a maximum of 30 days, and in the advanced settings you can specify different hard warning thresholds, as well as specifying a different data store in which to store the journal. For RPO alert, this is not a schedule, this is just an alert. If the recovery point objective goes above, for example, the 5 minutes here, you will be alerted by alarms and email alerts. And a test reminder, again, is just an alert that if this hasn't been tested in this 6-month period here, you will be alerted. We have some advanced settings, so you can change all of these per VM if you want to have different maximum journal sizes, different journal locations, all of it configurable per VM. Next, we see a list of all of the VMDKs in the protected VM. You can set them to go to different target data stores, and a really cool feature is temp data. If you have a SQL database, for example, and you have the temporary database on a separate VMDK, select temp data here. We'll do an initial sync of the disk, but we won't waste any bandwidth or journal space replicating subsequent changes, which can save you up to 50% of your replication traffic and journal space usage, so very powerful feature. Then we need to select the recovery site network and folder mappings. So for a failover move, I want a production VM network. For testing, because this is a local replica, I'm going to use an isolated restore network. So it has no routing to production. This is just a list of all of the port groups that I've already created and presented to the host. So whatever network mapping you want for a test to make sure it's isolated, completely up to you. I then select a recovery folder. I can specify pre and post recovery scripts which are run from the target Zerto manager, and again all of this is configurable on a per VM basis as well as a per NIC basis. If I wanted to send different NICs to different port groups or configure automatic re-IP addressing if I need that between the subnets or sites, you can configure that here in advance so Zerto automatically applies this using the VM tools. I've now created this protection group, I click done, and Zerto is going to do an initial sync of these VMs in the background. The next step is configuring another protection group. I can protect a new group of VMs, the same VM, and for this demo, I'm going to demonstrate the new one-to-many replication feature in Zerto. So I'm going to pick the exact same VM and create a remote replica. Search for the same VM here. And you can see it's not in the list of unprotected VMs. Why? Because I just created it in a protection group. So we need to click on Advanced, select VMs, multi-target, and here we can see my file server already in a protection group. I click OK, next, and now I can select a different target site for the exact same VM, showing you the power of the one-to-many replication. Maybe I want to replicate this VM into Azure. I don't select a host because there's no concept of host in Azure. I still get my SLA settings around the journal retention and the RPO alerts and test reminders. I can still select the temp data capability, but again, there's no concept of data stores. It's all stored in a storage account. But one thing's very important is I can select the VM network, the subnets, the network security groups, and the instance family and sizing of all the VMs by default in the group. And I can change this for each VM to make sure that I'm selecting the correct size for this VM in a recovery scenario. And it's the exact same options if I come back to replication target here and select AWS. Again, SLA settings, same storage capabilities, and then the recovery I've got VPC network, subnet security group, and again instance family and type. And you can see extremely powerful, extremely flexible. Whatever settings you need, you pre-configure on this virtual protection group so that you don't have to worry about it in a DR scenario because you configured everything in advance. So for this demo, let's create one, and we're going to replicate between my own two data centers. So I'm selecting my vSphere Boston DC2. Again, I can select the cluster. I could select a resource pool. I'm going to tie it to an individual host. Select my data store. I'm going to keep a journal history of 1 hour. Next. Next. I'm going to select my VM network for failover, an isolated bubble port group for testing, and then recovery. I'll just select a folder I pre-created there. I have the same IP range between my sites, so by default Zerto is going to keep the exact same IP, and then I click done. For your own proof of concept trial, I recommend creating a couple of test VMs, a Windows VM, maybe a Linux VM if you have them in production. Use those for your first replicas, both local and remote, so you can do full failovers, testing, and have no impact to production. And once you prove that out, then you can scale it out and start protecting some of your tier 1 production VMs to show the power of Zerto replication in real world workflows. Once we finish this initial sync, Zerto will then be in a state ready for us to go to the next step of doing failover testing and file level restores. Now that our VMs are protected in virtual protection groups, we can start to test out some of the cool functionality in Zerto Virtual Replication. Here on my status dashboard, you can see I have 2 protection groups protecting 2 VMs, 80 gig of data, and a sub 20 second RPO with no snapshots, no performance impact. In the bottom right hand corner, we have the live and test failover button. The only difference between the two is the live failover is going to connect the virtual machines to a production port group that we specified when creating the VPG. Test will attach it to the isolated network to ensure there's no impact to production. If we click on failover test, you can see we've got a remote and a local replica. I'm going to start with my remote replica. And if we click on checkpoint, here you can see the point-in-time recovery capability. So using the journal-based protection, which you could set to store on a different data store, you can see the ability to test and rewind to increments in seconds. So let's go to just a couple of seconds ago, next, and then start failover test. And what we'll see is Zerto bringing a failover test VM online in the target data center, vCenter, System Center, Azure, AWS, whatever I selected to replicate to. It's going to attach it to that isolated network, but it's going to do this without breaking the replication, so you can use your Zerto trial to prove your recovery capability in working hours, in minutes, with absolutely no impact whatsoever. While we're waiting for that test to complete, I can also do a file level restore. So Zerto is continuously replicating and protecting the data. If somebody deletes a home folder at 5 p.m., rather than having to accept the data loss of going to the last backup or snapshot, you can use the same journal capability in Zerto to pull individual files from seconds before they were deleted. So if we click Restore File, select our file server VM, and we're going to use our local replica, restore it from our second replica in production directly to production. Again, you can see the journal-based point-in-time recovery, so we could go back to just before 2 p.m. if someone deleted it, for example, just a few minutes ago. We click Next, we select which disk we want to mount, and then we start the mount. And all this is going to do is the same process as a failover test, but just attaching the disk to the Zerto Virtual Manager, which is then going to allow us to browse the file system and pull any file or folder or group of files and folders from that Zerto Virtual Manager. We can then download them through the web browser and restore them to any location, the original, the new, attach them to an email. It is completely up to you what you do with this process. So you can now see this process is finished. We click Browse. I can then browse the file system, and I can select file shares, individual documents. I could go into marketing here. You can see I've got the PDFs. I could download all the PDFs, maybe just one. Click Next, start download, and I now have that file. That is so simple. This is definitely going to be one of the top things that you want to test in your trial, as well as the failover test. So we come to this failover test. We can now see I have my file server 1 testing recovery, and at this point this is just a VM in the inventory. You could also restore files from this VM here, application objects. If it's a Linux VM, then you can log in and get the files from the Linux OS and not even use the file level restore process. The options are endless. Think about your Windows updates. If you need to test Windows updates against all of your infrastructure, rather than having to do it in production or restore from backups, you can just use your Windows failover test. The same for application upgrades. You name it, this is a Swiss Army knife in your data center, being able to rewind and recover your VMs from any point in time and recover individual files, recover the data, and this is all with no impact to production and no break in the replication. So this is just a few things that you can do in Zerto. The next thing you can do is stop the test, and you can actually then produce PDF reports that detail the outcome of the testing. So for any compliance, regulatory, auditing purposes, all you need to do is once we stop this test, we're just going to close this box down. We're going to come across to reports, recovery reports, and we will see the recovery report generated here, which we can then select one or multiple, and then we can click to export it as a PDF. And this gives you a detailed overview of exactly who tested it, when they tested it, the outcome, and the detailed recovery steps. And you can sign it at the bottom, and this is allowing you to show that you tested Zerto, you tested the failover, this is how long it took, and this is the outcome of your trial, and this product is ready to implement in production. So there are many other things you can do. Go and check out my Zerto, go to the forums, check out the test plans, the documentation, maybe look at some automation examples from the REST API document. Everything that you want to do, you can do with Zerto Virtual Replication. And hopefully you enjoyed installing this trial. You're going to test out some cool things, and I look forward to seeing you as a Zerto customer.